Later treatment can also greatly help recovery depending on how we go about it. Okay, because one of the bigger risks, even if you are out of the woods with the ischemic stroke in terms of getting TPA early and breaking up the clot and moving it along, you might still have problems. Remember apoptosis, right? Remember how neurons are programmed to kill themselves unless they're receiving nutrition from their neighbors. So if their neighbor cells died in this initial stroke event, they have a risk of dying too because they're no longer receiving those messages. So you can have this snowballing effect of apoptosis that's not developmentally normal in this case. It's not supposed to be happening, and it's actually making the stroke symptoms worse, like loss of speech or paralysis and those types of things. So the goal here is to prevent this snowballing of apoptosis, and that whole snowballing of apoptosis is called diaskesis. That's the italicized word in your book I want you to look for. DIASCHISIS. Diaskesis. I forgot to put it on the slide here. So later treatments are aimed at preventing diaskesis. The way that we can keep our remaining neurons alive is by making sure they fire a lot of action potentials. They need to be doing a lot of activity. So we need to increase stimulation. We can do this through administering drugs that would make the remaining neurons really active. We can do this through also increasing your physical activity. Because experience is part of how you increase the activity of your brain as well. Now, I have a kind of wacky story that I heard at one point a few years ago that helps me remember this. So here's your background about it. Dopamine is a stimulant, okay? It is a neurotransmitter. It's a chemical that's already in your brain that communicates between neurons that makes certain neurons fire more, and that tends to make you more physically active and more motivated, more upbeat. Many drugs that are uppers that give you more energy either trick your brain into thinking that they're dopamine or they make you produce more dopamine. Okay, so that's part of what this chemical already does. Here's my background to my wacky story. We're getting there. So doctors do administer, in some cases for later recovery of stroke victims, they will administer drugs that are dopamine agonists, meaning they increase the amount of dopamine or dopamine-like substances in your brain to keep your remaining neurons more active. Well, here's some other background that seems totally unrelated. In North Korea, their economy is very bad because they are a country that doesn't play very nice with others and people don't like to trade with them, right? And we also have trouble getting news from out of there because the borders and the information is very strictly controlled in this totalitarian state. In North Korea, because their economy is so bad, because they don't trade with many people, it's mostly China and Russia propping them up with oil and things like that. Nobody else is allowed to do business with them. They resort to black market means of keeping themselves afloat. So you see this in some countries. If they have access to the internet, they tend to do a lot of scams and stuff like that because there's not a lot of other economy going on. But North Koreans don't even have the internet. So in the 90s, what they started doing was drug production. The government itself actually started factories producing crystal meth. Meth and any other uppers, remember, any other amphetamines especially, are dopamine agonists. They mimic the effects of dopamine or make your body produce more dopamine than it already has to give you more energy. Now, they've shut the factories down. It's been several years, but people still trade this stuff all over the place in the black market. Some estimates have around 70% of the population addicted to it. People do it just as casually as you would see folks smoking cigarettes outside in many places, and it's the most popular Lunar New Year gift in February every year. North Korean people had found miraculous recovery of stroke victims by giving them crystal meth. I know there's some drugs that are medicinal. Crystal meth is not one of them. It's more likely to put you at risk of having a stroke. They found miraculous recoveries, supposedly. Now, you know, the news is difficult to get out of North Korea, so take it with a grain of salt, if you will. Hopefully not any blue grains. And what we find is people reporting miraculous recoveries of stroke victims who were given crystal meth. But they could have had those miraculous recoveries in movement and speech in the later stages of recovery because they were given a dopamine agonist, which is also what doctors in the West administer, albeit not in crystal meth form, in a slow release safe form to stimulate signaling in the brain. Not only can we sometimes retain the cells that might have died otherwise through apoptosis and this snowballing diaskesis process, sometimes we can actually regrow pieces of damaged cells because sometimes the entire neuron might not die. Sometimes it's long arm-like axon that sends messages to other cells. forms a synapse with other cells will be broken off or something. It will like wither away because it didn't get enough nourishment. The nucleus of the cell might still be in good shape. And over time, your cell can regrow its axon. We can also have, let's say, cell A and cell B were both talking to cell C. They both had a synapse where they were sort of talking to this third cell. Their axons both sent messages to it. If cell B died from the stroke, okay, now we've only got cell A. And cell C up here is used to receiving messages from two cells. So what we could have is what's called collateral sprouting. Cell A can pick up the slack and grow a new little branch off of its axon to talk to that sort of missing spot on cell C. And when that happens, sometimes people can recover, and when their axons regrow, they can recover some of the functions that they had damage to, like parts of their speech and movement, as they're recovering from their stroke. And we can speed these processes up, actually. There are compounds, there are chemicals you can administer that speed up regrowing axons and speed up collateral sprouting, which is when the axon kind of takes over the functions of a missing cell. What tends to promote these even more than drugs, though, is experience. If you have some paralysis in your right arm after a stroke, you have some difficulty moving it, a treatment that they can actually do is tie your left arm behind your back and make you use your right arm so maybe you can move it a little bit, right? And the more you practice it, the more your brain is likely to regrow parts of the cells that would take over that function to help you move your arm like normal again. And if it was, let's say you could move your arm fine, but it was sensation, you couldn't feel, it was numb, okay? They could still, again, tie your left arm behind your back and have you experience a lot of sensation through that numb right arm. The cells in your hands are still good. There's a connection broken in your brain, right? So we can get your hand receiving these signals over and over and over, and eventually the pieces of your brain might kind of grow back to reconnect this missing connection through regrowing axons and collateral sprouting. This is a good thing. It takes a long time and it takes a lot of physical therapy and experience, but it can be very helpful in conjunction with dopamine, in conjunction with having more social activity, trying to speak and trying to move more. However, all of the processes that promote this regrowth also promotes problems with it. So remember our collateral sprouting scenario where cell A regrew kind of an extra little arm of its axon to replace what cell B used to do? Well, maybe it's not sending the same message as cell B up here to cell C. Maybe it grew another arm, but it's sending the wrong message. And that wrong signal tends to come across as pain, like chronic nerve pain. You can't do much to treat this pain because it may hurt in your leg, but it's not your leg that's damaged. It's part of your brain. So all of the drugs and therapies that make regrowing axons and collateral sprouting happen can also cause this supersensitivity, which again is chronic pain due to your nerves, due to your neurons growing unusual connections.